So, Mike, 3 things to consider before starting a planning application.
I think one would be to check the planning policy that you have in your area. They're very different in different parts of the country. So be familiar with if there are any additional requirements that they require of you. I'd start early. The earlier you can start, the better to ensure that you've got that time to adjust and flex a design. And I'd also make sure that you're considering all of the broad energy, overheating, associated kind of guidance. So part L, part O, part K, elements of building regulations, so that you're designing something and submitting something which is going to enable you to tick all of the right boxes, both for the planning authority and ultimately at the end of the project.
Cool. Give me 3 things that you would expect from a good, credible sustainability consultancy.
I think you would be asked questions around what you're trying to achieve and why. So trying to understand what the drivers are, whether that's compliance, whether that's a particular metric. I think you would be challenged at times as to why you're using certain fixed building services or approach to fabric. And I think you'd also be given ideas as to how you can tweak and adjust things. So there'd be discussion, there'd be collaboration and coordination. I think you probably see from a good company.
Give me 4 reasons why buildings do not pass Part L compliance.
I think one could be to do with changes of product on site during construction. We see it sometimes where a particular block is linked to a SI value that's used.
So switching out specification.
Yeah,
Yep.
so that kind of that changes round.
Number 1.
I think starting too late to engage with things.
Engage with things.
So to engage with the calculation, sometimes we get contacted at the end of the project and the calculation is an afterthought. So we build based on how we've always done it, but the methodology's moved on and we find ourselves just a bit behind the pace. I think the third thing would be the choice of heating system sometimes, and the heating system doesn't perform as well in the calculation methodology as we would anticipate. And again, it's not been done early, so we find ourselves lacking in short. And I think the other approach is that the fourth weight would be around the psi values, and sometimes there is a lack of attention for the psi value around the building. If there's a particular building typology that you're using, which requires kind of linear thermal calculations, and you've not got those, and you're using kind of old values that you just assumed were still okay, that can also be an issue.
So, Mike, tell me the 2 things that are on the horizon at the moment for the construction industry, but that no one's talking about, but that will cause us a major problem.
So I think coming up on the horizon, we've got whole life carbon. So at the moment, we are declaring net zero based on regulated emissions, and we're not accounting for whole life carbon. So we know that that's going to come up in the next X number of years, but that will come out of the shadows, out of planning policy requirements and into more mainstream requirements. We'll have to consider that, factor that in. The other aspect of that we're not considering at the moment is unregulated emissions. So anything with a plug on it, if it's fixed, it's to do with heating, lighting, ventilation, it gets accounted as part of the calculation procedure. Anything with a plug on it, there's an assumption as to how much will be used in a dwelling based on a calculation methodology. But we will likely have to account for that. And the more and more we use within our homes, the greater kind of aspect that this is for carbon emissions, for energy use. And so I would say unregulated emissions and whole life carbon are 2 things to keep an eye on.
Give me the top 3 risks that are facing developers at the moment.
That's a really good question. I think the first one would be house type design used across the country. It may be that there's a multiplicity of house type designs you need to kind of adapt and adjust with weather files and different shading options. I think the approval process for one design to go across the country will need to be looked at, and there's a risk there around money, time. I think the second thing is making sure that the amount of individuals needed to collaborate early in the design process are brought together. And with bringing people together earlier, there's increased fees, there's increased time. And so that's, again, something to factor in. And I think linked with that is probably the sequencing and making sure that there's no delays. So at the moment, you get your architectural design, you get your SAP calc, you then get your M&E design, and you move forward through construction and as-built and so forth. The timing and sequencing of having certain design team members inputting into that process, and where that works, there's a risk that will slow down that development process. And so your ability to go from design to site, it's a fresh approach. There may be some delays there. There may also be some complications. It's a new process, a new sequence of doing things. And so that needs to be looked at, that needs to be redesigned to avoid delays and avoid any miscommunication between the different parties.
What do architects need to stop doing in their design process?
So what it will be is around the specification, written specification, and numerical declaration of U values. They don't add up.
Okay.
They and there's so many specifications where they don't add up, and so there's confusion. Fine. There. Over reliance on U values. So what happens is you don't account for the heat loss through the psi values enough. So what happens is the initial specification is it leans on the requirement for the U value too much. You get big walls. You don't need them. They're too costly.
Why are the build costs so horrendous at the moment?
Because they're not addressing, because the design team aren't pulling in an energy assessor or somebody that knows about thermal junction modelling. There's an over-reliance on U values. So the U values are coming through it at planning stage at 0.13. Then they're quite happy to be at 0.18.
So does that mean the project doesn't go ahead because it's a price too high?
So what it means is build costs. So what it means is that developers need to identify those anomalies.
So the developers identify it, not the architect, not the M&E consultant.
No, so like for instance, I'd give you an example. So Vistry will come to us with a new scheme saying, Mike, go through, find out all my risks and where I can VE. Because the architect, an example recently, the wall's at 0.13. But when I actually calculated the wall U value, it wasn't 0.13. In certain areas, it was massively higher than that. Or it doesn't need to be that low, because what they've done is they've not appropriated the psi values in the right way. So information being provided is not as in-depth as it needs to be. It's high level, it's repeat, it's not got the specialist in there, it's copy and paste, we need to do that U value, and here's our specification, but they don't actually match up. Those are the issues.
Mike, why do buildings get over-specified?
When we get specifications through, the numerical declaration on the specification and then the build specification don't always match. So create confusion. So that needs to be something that's worth looking at to make sure that what is declared in terms of how the building is going to be built with the numerical value and the U value, that they're going to match up. What we can also find at the beginning of a large project is that there is a over-reliance on U value for fabric performance. It doesn't need to be that high. It can be pulled back a tad if there is a combination of psi value, G values, and U values, where those three things, where you use a consultant that can look at those three different values and how they combine with each other. It can conserve the amount of insulation that's needed on the wall, which can conserve revenue and reinvest it elsewhere in the project. So sometimes projects are over-engineered where there is an over-reliance on one particular thermal parameter, or where specification is either copy and pasted, or where there's not complete coordination between the specification and its declared values.
Boom. Mike, what is embodied carbon?
Embodied carbon is the capture of carbon or the use of carbon in the extraction of the material, its processing, its incorporation into a usable material, its transportation to site, its construction on site, its life and duration in that particular form. It's either adaptation or recreation or reuse again, or the end of its life process.
What is the biggest waster of energy in a UK home?
I'd probably say it is to do with the way we use our homes. So, for instance, it's turning the heating down a tad when we don't need it. You know, it gets set at a certain point and it gets left at that point and it just comes on and off. And when we get hot, we open a window. Yeah, let's turn our heating down a tad. Let's put the shower on as we're waiting to get into the shower, not put the shower on, go off, get sidetracked with something else. Let's turn the lights off in our homes. Let's use our appliances at the right times, potentially. You know, let's use our tumble dryers kind of later in the evening, or let's not use them at all. Let's, you know, switch them off during the summer and go outside and use the natural resources that we've got to dry our home, our clothes. Let's speak more around the sink and use that time to catch up with each other and have a family activity while you're washing up. So there's lots and lots of things we can do, like turning the lights off. I think the biggest waster, though, is literally engaging in an activity too early or not adjusting the set points of certain things based on routines.
What do most people not understand about UK new build homes?
UK new build homes are going to incorporate air source heat pumps. Low temperature heating is on all the time. Keeps an ambient temperature. You don't have to switch it on. You don't have to switch it off. I think most of us are used to using a gas boiler. You switch it on, you switch it off, you set a point for it to come on, a point for it to come off, you turn it off for the summer, turn it on for the winter, whereas this new technology incorporates background low temperature heating. That's the biggest change.
Love it.
You know, you go for an interview and they say, what's your week? What's your downside? I'm a perfectionist. It's very much like that. I connect to people on a personal level really quickly, and that's a strength of mine, I think. But it's a weakness because all of a sudden their problems are mine. And so all of a sudden I've taken on the world's problems. They're not mine. They pay me to provide a solution, but you know, that's the service level that they get is someone that is just plugged them into their issue when it's or. You know, I feel personally connected with that.
Have you found that has held you in good stead, though, taking that approach of my approach to this service or this customer's problem is so personal to me that I'm going to give absolutely everything? Have you found that has stood you or had you in good stead?
Yeah, I think it's one of the ways that we differentiate ourselves from other people is how we interact, how we connect. And so, yeah, so it really has done over the years. It's been a real plus point, but it comes with its downsides, you know. It's difficult sometimes to disconnect. It's difficult to
You're talking personally to disconnect.
Yeah. And also if you get stuck in the middle of something that you can't put right or you can't get the right result from, then it remains with you or it has its impact. So, like with everything, there's two sides to every coin. And so, you know, being able to connect with people, make a difference, collaborate quickly, you find solutions to problems rather than this is my silo and I'm going to stay in it. I'm quite happy to stick my 2 feet in and get involved really quickly. But it does come with that cost when the solution is not easily found.
You've got a vast amount of experience, 16 years in the business, working with some of the biggest organisations that we've got in the UK, solving some of the biggest issues, lots of regulation changes, so on. What advice would you give to someone that has got an aspiration to get into this industry, but they've maybe just finished university or are starting an apprenticeship? What guiding principles would you give for them to follow?
Let's do it. You know, believe you can do it, get involved. I didn't come from construction background. And again, that's got it's got its upsides and its downsides. You know, you're able to think about things in a different way, and you come with a different skill set. But I don't think the industry has any barriers for people to get into. So if this is where you think you want to apply your trade and you'll find enjoyment in that, then get involved. There's loads and loads of material and information out there that you can read and become familiar with. I think trying to get involved with an organisation that can hold your hand and help you has got a good training program. I think it's an industry where you can learn on the job, and you can find success and you can find job fulfillment quite quickly in some of the tasks that you can perform. So everything that I've learned and that I've experienced is if you want to get involved in it, then do it. Get involved with it, find a way, speak to a number of people.
So someone wants to get involved and they want to do it, and what attributes, what skills, what advice would you give to help someone progress along that career path? And when I say that career path, I guess what I'm meaning is someone that wants to be a sustainability consultant, someone that wants to look at buildings and try to make them more sustainable, or get to net zero, or meet compliance. What advice would you give?
So hard work is essential. If you want to be good at anything, you need to be willing to put the work in. So I think hard work's really key. I think being inquisitive is again, like if you come into the industry and you know nothing, just be inquisitive. I remember when I started, I was struggling I thought a stink pipe at the top of a house was a flue. You know, just be vulnerable. You know, be okay to be vulnerable, to ask questions, to seek guidance.
So just break that down. I'm going to jump in here just for, I think, the benefit of people that don't know what a stink pipe is and what a flue is. So
probably still.
So you were. I remember that scenario very, very well, and I think it will stay with me forever. To be honest with you. So just help me understand or remember what a stink pipe is and what a flue is, and how they're so different, and how you could even muddle the two up.
Even now, I know that they're different, and I can spot them different on houses. But yeah, flue gets rid of all the kind of combustible gases out of the heating system, and a stink pipe gets rid of the smells from a house that you don't want going anywhere else. Stink pipe tends to go up, out, and gone, and a flue will go in different places. It might go horizontally, it might go vertically, but they do very different jobs.
They get rid of waste, right? Both get rid of waste. But one of them is connected to the drainage system, right, which is connected to the sewer under the house. So it stops your toilet and your sink and your bath kind of smelling of the sewer. And that comes out generally the top of the house, right? Far away from windows and all the rest of it. But your flue is, like you said, connected to the boiler, which comes out generally the side of the house, or sometimes it's in the loft, but it's connected to the heating system. So that's funny.
But just being vulnerable.
That's funny.
You know, just acknowledging the fact that you don't know stuff. Mm-hmm. I don't know stuff. I'm going to ask, take a guess at something, and that's how you learn. Mm. Like, I will never, ever forget that experience. And there's a few other experiences as I've gone along in the industry where I've learned things and they've been stamped onto my memory.
Can you share that?
Just around when I was first in the industry, working through one pitch roofs. You know, I'd grown up in a house which had a cold roof, loft. So
what's the difference between a warm roof and a cold roof?
So a cold roof, if you go up into your loft and the insulation's at your feet, then you've got a cold roof space. It's insulation at joists, that's where you'll see it. Usually the mineral wool that everyone believes is really super itchy.
So the mineral wool is that fluffy stuff, can get a little bit itchy. If it's really old, it's kind of a yellowy colour, and it's a bit of a pinky colour if it's fairly new.
That's right.
Generally speaking.
Yeah.
Okay.
And then,
so if that's on your feet, when you go and stand in your loft, then you've got a cold roof. Yeah. Is that what you're saying? Okay.
A one pitch roof is where you'll go like into a 2.5 story house, or a kitchen where you've got a sloping roof. So the insulation goes between and over, or a combination of those spaces with the rafters.
And the rafters, the bits of wood in the ceiling going from top to bottom at an angle.
Yeah,
Is that the rafters?
angular, rather than horizontal. Yeah.
Okay. So, sorry to jump in there, but you were explaining the point of you not knowing the difference between a warm roof and a cold roof. Is that where you were going?
No, so it was really just the construction and where the insulation goes. Having not come across that roof construct, I wasn't from the construction industry, and so how building materials go together and their location and how they interact with each other, how they're held in place, they prevent moisture from moving around, how they allow airflow. These are new concepts to me. So early on, particularly, I remember when I was first a non-construction assessor, SAP assessor, I'd come across, I'd get plans through and they'd have a sloping roof and like, oh no. So, and I'd sort of have to ask questions. And as those questions get answered, it was a particular learning point for me that I've always remembered.
So it's good now, 16 years on, you are still, it sounds like, in the space where you want to learn more. You've got questions, but they're just higher level questions than what they were when you first came into the industry.
Yeah. It was always good to have questions. There's always things you don't know. And again, being vulnerable is like super, super important. Being able to, I think that's one thing I've tried to come to terms with over the years, is it's okay to not know the answers to things, but also be knowledgeable in a particular area. It's okay to have that, and to be open with customers and with clients in that approach is really, really important. I think starting in the industry, there's this, you need to know everything and need to be like everybody else. And I think just being honest with customers, honest with yourself is going back to what you were saying around what you would need coming into the industry. I think there's definitely hard work, but I think just being honest and being able to be open to learning and say, I don't know that. Let me find that out. I think there's a confidence that people can take in that, rather than trying to give this waffly answer that someone says this doesn't add up. So I think it's really important. And now there are things that I'm learning about and finding that my work life is being enriched by just different concepts or even really easy concepts that I've just never had to get my head around. But I'm really interested in understanding how that figure or how that calculation or how that approach actually works.
What's the big thing that's going on in the industry at the moment? What are the puzzles that need to be solved?
The big anticipated introduction is the Future Home Standard.
What is that? The
Future Home Standard.
Yeah.
So
and who's even come up with the Future Home Standard? So what is it? Who's come up with it?
The Department for Levelling Up, DLUC.
DLUC.
I might have the acronym. Yeah.
Department for Levelling Up.
Yeah,
DLUC.
I probably got the acronym wrong.
DLUC.
DLUC.
It must be DLUC with a K.
Yeah, and then with a C.
With a C.
I think.
Levelling Up. What's the C for then?
I don't know. You're asking me acronym. I don't know. Department of Levelling Up in Communities. Don't know.
Okay.
We can find out. I made it up.
All right.
Just made it up.
Like that. But the Department for Levelling Up, that's not made up.
Who knows?
That's a true one.
Who knows?
All right, fine.
Who
So
knows?
there's a department somewhere.
Who knows?
Some government quango.
Who knows all the acronyms? But yeah, so DLUC and DESNAS are primarily the kind of two departments that are leading on this. DLUC are doing the Future Home Standard, coming up with the standards that we need to comply with in and around Part L, and DESNAS are driving the home energy model, which is the replacement for SAP.
Okay. So let's just kind of clear a couple of things up here. So are these government departments or are they industry bodies that have come together to make a difference?
Government departments.
Okay. And what's the whole premise behind this then? Why have the government set up departments to look at these two elements?
So I think the departments were not just set up for delivering these things, but they've taken on a responsibility for it. Someone somewhere needs to have policy, and the departments are leading on the creation of that policy and the delivering of that policy.
Okay. And the reason for the policy is?
To help us to achieve net zero. We've got these targets to achieve net zero.
Okay.
2050, buildings emit lots of carbon, And so we need to reduce the amount of carbon that we emit, to reduce the amount of the amount of energy that we consume. And so these policies drive behavior, drive regulations, drive the way that industry interacts and presents products to consumers. And so that's what we're anticipating now. The consultation is completed for both of those. It was 3 consultations, but they've been concluded and we're just waiting for the feedback now.
Okay, so it's just kind of if I can just kind of go back. Sorry to keep dragging you back, but we've got these departments that are responsible for making change in the industry. The overall premise of the reason for the change in the industry is so that we can reduce the amount of carbon throughout the construction process, as well as the amount of carbon that's used in the buildings that we have. Is that right?
Yeah, the policies at the moment, particularly around the change, are less to do with the amount in the creation of building products and more to do with kind of assets and the way that the building performs as an asset, as an
overall entity. Fine, okay. And so you mentioned the consultation. What are they consulting on, and why does anyone really care?
So before regulations change or before big adjustments take place, there's a consultation that will be released. Industry, individuals get a chance to have their say, present evidence as to whether something is appropriate. It's always nice to get people's opinions as to whether something's been missed or whether something could benefit from an adjustment or a tweak. And so that's what happens. So there's a change to the software that's going to be used. The home energy model is going to replace the standard assessment procedure. So there was a consultation on that. There was a consultation on the way that the home energy model deals with the future home standard wrapper, which now goes around the home energy model.
Okay,
and there was a consultation on the future home standard itself and the standards that are going to form part of it.
Okay, so we need to kind of go down and just break this down a little bit more. You're speaking about wrappers, you've got home energy models. I'm thinking Kit Kats and Twixes. Is it what's going on? So this need for reducing carbon in properties, in homes. There are 2 government departments that are trying to do that in different ways. Do they come together? And if they do come together, how do they come together to work together, or are they at odds with each other?
The answer is they must be they'll be collaborating together.
Okay.
But they've got to deliver different
elements of
different elements of the approach.
Fine.
The approach is going to be a change to software, a change to the regulations, and different departments are delivering different parts of that.
Okay.
Of that.
So that's what's been decided. The decision is the current structure that we've got, and you made reference to standard assessment procedure, or the acronym is SAP, SAP, which could be confused with the computer protocol, which some people do. That's the current incumbent method of addressing that scenario, correct?
Yeah, SAP's been used for over 20 years.
Fine. And so just talk through SAP really quick. Where are the strengths of it? Where are the weaknesses? What's it really designed to do? Is it a design tool? Is it not a design tool?
So SAP delivers a result against Part L, building regulations. So it's designed to receive lots of inputs around a building, the way it's designed, its fabric, its fixed building services, and then produce and that result is then either compliant with or not compliant with a standard which shifts relating to Part L.
Okay. So you mentioned Part L. Part L, you've mentioned, is part of building regulations, but what actually is Part L within building regulations?
So it's to do with the conservation of fuel and power. So it's the carbon we emit, it's the amount of energy that we use within that building.
And is that applicable to every single property?
Yes. So,
new build, this is?
Yeah, so SAP will be something, or Part L is relevant to every new building that's built. Part L also covers a retrofit or change of use, but there's a slightly different set of standards that will be applied to that. So yeah, you would need to check against a set of regulatory criteria to see if you're compliant.
So clearly SAP can't be the holy grail, as in we've reached the pinnacle of everything, because if it was that, then it wouldn't need to be changed. Is that a fair assumption? And so what are the limits to SAP if my assumption is correct?
So, as I said, it's been around for a long period of time, and it's been adapted for different uses. So we had the inception of the EPC that came in, which enables properties to be compared in terms of their environmental performance. SAP's been used as a design tool. You mentioned earlier on about it's not designed to be used as a design tool, but dwellings have got to comply with a regulatory standard. So you can use it as a tool to see how particular designs fare when put in the sausage machine. So it's been used in that way. But like with every, I guess, tool or process, as time adapts and as policies adapt and as requirements adjust and change, you, like building a go-kart, you bolt things onto it. It might be easier to start from scratch and actually design something which is specific for what we want it to achieve. And so SAP is adapted, it's been adjusted, it's been tweaked, it's been maneuvered, manipulated to deliver different things over the last 20, 25 years. And what we're seeing now is we're just going to start from scratch. We're clear about what we're trying to deliver, which is net zero in buildings. And so it's a new tool to help us point towards that.
So SAP, if we use the go-kart analogy, was created initially for a purpose, and then we realized actually we need to tweak this and add that. And so the go-kart got modified. And so now what we're doing is we're saying we need to get rid of the go-kart and we need a different vehicle because we're clear on where we want to go, and a go-kart's not going to make it there.
Yeah, go-karts, they don't go uphill. So maybe you've got a hill you want to climb, do you know what I mean? So you need some kind of power or to bolt on. A friend of mine once took a pair of shoes and put some roller skates on the bottom of them, and that way he made his own roller skates. But so the shoes became roller skates. They look like shoes with wheels on. Roller boots.
What
roller
did you
skates.
use? Screws?
I have
Nails?
no clue. I genuinely
Duct tape?
I have no clue how it worked. All I know
Did
is
you have a
that
go?
when we were kids, I had my roller boots, and he had these shoes with these wheels on the bottom. He was flying around. But yeah, we need a tool that delivers a particular outcome, and we've adjusted and adapted and tweaked and.
Yes, come on. We're excited for this moment.
Yeah, when you're designing something specifically for a purpose, it should be better suited to deliver what we want. So it's a more dynamic model.
So when you say dynamic, what I'm hearing is complex. It's more complex.
So with SAP, they took a picture every month. You had 12 data entry points, whereas in HEM, it's every 30 minutes.
When you say take a picture, what do you mean take a picture?
So the report, the calculation methodology, it uses data in SAP every month. It's monthly data that gets input into the calculation methodology, which produces the result.
So that data is what data? Weather data? What do you mean? by data?
So with SAP, that it only uses one weather file.
Right.
So East Pennines, everything's based on that weather file. Whereas
Even if you live in London, East Pennines.
Yeah.
Right.
And HEM will use, I think it's 12 different weather locations.
Okay.
So specific data,
Yeah.
you're able to, so SAP uses 12 data entry points, one for each month. HEM uses one every 30 minutes throughout the year.
Okay.
So
That's a lot more.
yeah, it's over 17,000 data entry points that it's trying to calculate. So it's got the ability to, let's say, be more dynamic in terms of the data entry, flexible around how technologies are able to kind of deal with changes in temperature or different set points throughout the day. If the technology is able to adapt and adjust, there's more capacity for the calculation to reflect that and represent that in an accurate way, whereas the current SAP methodology is very much square peg round hole. When you've got something which is quite innovative and is seeking a dynamic approach, there is no data entry for that. So Appendix Q seeks to try and fit that data in a particular way, but it doesn't serve these innovative products in the best way. So yeah, so it could be great.
So, and what is Appendix Q?
Appendix Q it's an approach to getting innovative products into SAP. So if you're on the database, you're able to select a heating system, fixed building service system into SAP with its various efficiencies and so forth. If you're not on Appendix Q, if you're not on PCD or you're a new technology, then it's the approach that the government have put in place to be able to take the benefits of that technology and fit it into SAP. It's basically like a backdoor.
Oh, so I like the analogy of the back door. I mean, that resonates not just with me but with other people. But
yeah, so
coming out with other acronyms.
Yeah, so I think appendix. So the SAP has got the PCDB. It's got a database.
PCDB.
Yeah, product characteristics database. So you can pick boilers, you can pick heat pumps, you can pick ventilation systems. They're on this database with efficiencies already built in. So you select it and it goes into the calculation. Whereas if you've got a new innovative piece of technology, it has to go through an approvals process. And before it can go through that approvals process, you can use it in SAP before it gets onto the database itself. But it's like instructions how to use something. So instead of...
And this is what Appendix Q is?
Yeah, Appendix Q is like a special set of instructions for a particular technology that isn't able to be chosen off the database, and it's how you take the benefits of that technology and replicate them as best as you can in the SAP methodology. It's quirky, it's difficult at times to understand, it's open to error a lot more, and so the opportunity for someone putting it in and putting it in the wrong way is enhanced. So with HEM, that should be eradicated. So they're creating a new database as part of the HEM model. All Appendix Q, PCDB already software that's already, systems that are already on there will go on to that. And so the approvals process, the ability to kind of dynamically put on new models onto that should be simplified and made easier.
Okay. HEM being the home energy model. And if I'm an architect, what 3 things would you say I need to either do or consider? What 3 pieces of advice would you give me as an architect?
So it's really important to read the consultations and understand what's being proposed.
But I'm asking you just to help me out because I've not got time to read it. I want to pick your brains because you've read it and you understand what's going on, but I've not got capacity. I'm old. I don't even like being an architect anymore because it's changed and there's all these hoops that we need to jump through. And I've heard that you're really good at solving people's problems because you take them personally. And your customer service is outstanding. And I'm just wondering if you could just come up with 3 things to help a poor old architect out.
So I guess the 3 things that you need to bear in mind with HEM, and there's probably, unfortunately, more than 3 you need to consider.
What should people be investing in now for the home energy model?
So I put 5 action points. So one is otherwise build costs will be elevated beyond where they need to be, and we'd all rather invest money into making the building even more efficient than just being inefficient in trying to create a building which is just compliant. Overheating in residential buildings, there wasn't really...
Should I pursue either as a consultancy a silver bullet to solve all the problems, or should I look for